Okay, let's begin. So today we will discuss the last three behavioral pattern: template, mediator, and observer. So let's look at the overall picture. So the pattern in red we discussed. So this blue what we're going to discuss today. So basically, once we finish these three patterns, we are done with design pattern. The pattern in the design level. So next week we'll spend some time on the architecture. So then basically that's the wrap up of the of this semester. So let's look at the template pattern. Template method. The intention is to define a skeleton of an algorithm in operation, so deferring some step to the subclasses. So this allows the subclasses to redefine some step of the algorithm. So here we make the main algorithm intact, but some steps, if you want to do some modification, this template pattern, the template method can be an option for you to achieve that. So let's look at this example here. This example is from the Head First design pattern from that textbook. So here you have a cafe book and a cafe house, and here we provide two recipes, and your job is to, when a user choose these two recipe, you can display the steps on the screen. So to make a coffee, this is 4 steps: boil some water, and brew coffee in boiling water, and then pour coffee in cup, and add sugar and milk. And tea, you boil some water and steep tea in boiling water, pour tea in cup, and add lemon. So you see that just by looking at the recipe, you see there's some commonality. Then if we use the code to implement this, then we have a prepare recipe contain the 4 steps we have, and here then we have each of these methods implement one step. So similarly for the tea, we have the same prepare recipe method contain the algorithm, and then we have these four methods to implement each step. And later on, just by looking at the code here, we see there's a lot of duplicate here. And then see the client code. The main program. The main program, if you want to display the recipe on the screen, you create a new tea and create a new coffee, and then you just call the prepare recipe. Call the method, and it will display the step on the screen. So this is there's nothing wrong with the code. However, when we look at the code, and we see that there's a lot of duplicates. So whenever there's a duplicate, there's a sign that we can add some abstraction to remove some duplicate. So how we do that? We compile these two code. Then we see two things are exactly the same, like boil water and pour in cup. These two methods are exactly the same, so we can pull out them and then we just implement them once in a base class. So this is become the new design without changing the functionality. What we do is to have this prepare recipe, because this prepare recipe is different. Is different in two subclasses, in coffee and tea. So this prepare recipe is abstract, and since it's boil water and pour in cup are the same, so we implement once in this cafe beverage base class. And then if we look further, we see that it's not just this boil water and pour in cup. These two methods are different. Are the same. Their algorithm, the steps are similar. So here we see the opportunity to further abstraction. So we can abstract the prepare recipe too. So here we use the prepare recipe, boil water, brew, and pour in cup, and add element. So here we implement the boil water and pour in cup because these two are common in two in these two beverage, but the brew and the pour in and add element are different. So we make them abstract. So this will allow the subclass to implement this brew and add condiment. So here we have this the coffee is a subclass of caffeine beverage, and implement brew and add condiment. Similarly, tea will implement brew and add condiment differently. So here we see that we have additional abstraction because the prepared recipe, their steps are the same. Are very similar. So we can just implement it once. Here we make the final. So here we have the word final here, so that this prepared recipe cannot be overwritten by the subclasses so this is the key for the template. We want to make the template. There's no way you can change it anymore. Once we define a template, you cannot change the template. You can only make change to certain step, but the algorithm as a whole must be remain intact. So here, from the client point of view, you see the code is the same. So this gives you an example of a refactoring. So when we refactor code, so we don't want to change the client code, but we just change the structure of the subsystem, so that is more efficient. We can remove some duplicate. For the client, from client point of view, the functionality you provide is still the same. So here is one example of the template method, and then one we use template method. So here, if you want to implement invariant part of an algorithm once, and leave up to subclasses to implement the behavior that can vary. So here we localize the common behavior to avoid code duplicate, and that's another reason we use a template. And the third one is to control how subclasses extend superclass operation. So here we actually the template. We know that from here we make the prepared recipe final. So this means you cannot change the algorithm. However, by introducing the hook method, we can make the algorithm differ a little bit for different subclasses. Yeah, of course, in this particular example, we have only 4 steps. There's not much you can do, but once the algorithm become complicated, then by adding the hook in some strategic point, then you can change the course of the algorithm. For example, if you have an if statement here, and in that if statement, that condition is a hook function. So the hook can be a true or false. If true, then you go one direction. If false, you go another direction. So that's if we strategically put the hook operation in some place, then we can change the course of the algorithm. So we'll do that in our class access. So here, by introducing the hook, we can have some additional control on the algorithm itself. Even the algorithm itself is declared as a final. So this is a generic structure for the template method. We have an abstract class, then we have a concrete. So in here, the template method implement once, and then the template method contain operations, and then the concrete class can modify these operations. Collaboration, the concrete class relies on abstract class to implement the invariant steps of the algorithm and algorithm itself. So the concrete class just implement the part that will differ. So the consequence is, by using the template, we can reuse the code. Of course, we increase the reusability because the same algorithm can be used over and over again. An operation must be which must be overwritten by subclasses should be made abstract. And to prevent subclass from changing the algorithm, we declare template method as final. Then let's look at the example using hook. So suppose here we have a template method containing two operation, and then between these two operations we can add a hook method. We can make a hook method here. For example, instead of operation 1 and 2, if you want to do some do something in between, then you can add a hook. You can add a hook, and of course the hook is each. So here we do nothing in hook, and then the subclasses will implement the hook differently. Then let's look at this exercise. Let's spend some time on this exercise. In our caffeine beverage example, I want you to add a hook that give the flexibility to allow user to decide adding condiment or not. So in here, we want to put this hook method in a strategic point so that you can make a decision there, adding condiment or not. Now, for example, for the coffee, first ask a question: would you like milk and sugar with coffee? Yes or no? And then proceed based on user's answer. So in here, do similar thing for the tea. You can ask the similar question, and then tea say yes or no. Then you can go different direction. Here only draw the UML class diagram and then implement. Okay, let's work on this together. First, let's look at the UML class diagram. So we still have the prepare recipe is a template method. Now we have a boil water, pour in car brew, and add condiment. So this four still the same. So here we want to add a hook method. Customer want condiment or not. So of course this one is a boolean. Yeah, will return true or false. And then let's look at this here, where we should put this customer want condiment or not. So we put this inside this if statement. So customer want condiment, if true, then we add a condiment. Else we just else we just pass. So from here we put this hook in this if statement. We can change the course and go through this add condiment or not. So this is one example that even in this very simple example, we have only 4 steps. We still can put this hook function inside the if statement to change the way to change the course of the algorithm. So from here, so by default, this customer want condiment will return true. And then it's depend on how you overwrite in the coffee and the tea. So everything else is the same. The brew and add condiment. The only thing different is add customer want condiment or not. So we first get a user input. Of course, to get a user input, we first print out would you like a milk, and then you answer, and then you read the answer. And then you check the answer is yes or no. That you accordingly you return true or false. So if customer say no, then you return false. If you return false here, then you will not add condiment. So this is showing that we can adding a hook method and put a hook in the if statement to change the course of the template. So from user point, from client point of view, it's the same, still the same. This template method. So here is one example we use in the template method in refactoring the code. To reduce the duplicate and give user some control of the algorithm. The next method, the next pattern is the mediator pattern. So here we define an object that encapsulates how a set of objects interact. We call it colic. So in here we have one mediator to handle the communication, of a set of objects. So by introducing this mediator, we have a loose coupling because this object, they are not referring to each other. So if they want to communicate with another object, they communicate through this mediator. So that this mediator becomes a central hub of the communication. Then when we use these mediators, so here I give you one typical example, is an air traffic control tower. So here is for any airport we have is a control tower. So this control tower's job is to decide which flight to land or to take off on which runway and when, right? You cannot allow. You cannot let this plane to communicate with each other to decide when to land and which runway to land or which runway to take off. If you let them to communicate, then there will be chaos. So this communication can also, this kind of decision can only be made by the control tower. So this control tower is like a mediator, handle the communication between the flight. So let's see. So here we give one example. We use mediator. Then theoretically, why a mediator pattern is useful, is because of the OO design. Because in the OO design, we don't want to have just one object do everything for you. Then that will be have a major problem in the maintenance. And so we have this participant system into the main object. So that's why. So what do we do? So once we go into the detailed design level, we have more object. However, if we have this partitioning into the small pieces, then their intercommunication become an issue. So on one hand, we increase the reusability by breaking down the system into small pieces, but on the other hand, their communication reduce the reusability. So here we have to have a balance. Then in the software engineering, the decoupling and the cohesion is a trade-off. Of course, the cohesion is one object, just do one thing. If we really implement this way, then we increase the coupling. However, if we try to decouple, then this means we have less object. Of course, you have less object, then you have less coupling. Then if you have less object, then the cohesion decrease. So this cohesion and coupling is like a trade-off. So between this trade-off, the mediator can help a little bit. Yeah. So this will, by introducing a mediator, even we have a lot of objects, but we don't let them to communicate with one another. We let them communicate through this mediator. So even we have a lot of objects, but the communication channel is reduced. So this mediator can help a little bit, help you to balance, help you to increase, to reduce the coupling, even you have a lot of objects. So one typical example is the GUI. So here, for any application contain a number of GUI, and then of course this GUI widget, they have some dependency. For example, a button get disabled when certain field is empty, and typing into an empty field might automatically select one or more corresponding entries in the list box. So this when you fill the especially when you fill the online form, you see this dependency between the widget quite often. Then who handle? Then the question is who handle this communication? Yeah, who handle? For example, like if a button get disabled, one certain field is empty. So this button and this field has some communication. So who handle this communication? So there's two choices. Either you let them communicate them, I mean just directly, or we have a dialogue director to handle the communication. So in terms of the intercommunication channel, the second option will reduce the communication a lot. Reduce the communication a lot. So of course, different dialogue will use different dependencies. So think of two different windows that both have a button and a certain field. And of course, their interdependency can be different. And depending on what you want to achieve in different windows. So to not let this individual widget communicate with each other, so we have to create a separate mediator pattern. Mediator object to handle this collective behavior. So this mediator will be responsible for coordinating interaction among the widget and keep widget from referring to each other. So in here, the widget doesn't know other widget, and also they don't have a instance variable that's referring to other widget. Furthering, there's no if statement in the widget. So of course, and all the if statement and what happened for different scenarios are handled by the mediator instead of a widget itself. So this is example of a GUI form. So here we have a form dialog director. So this one is a mediator to handle the communication between the button, list box, and entry field, and whatever other widget you may have in the GUI. So in here, the list box and the button, you see they don't talk to each other. While in the real time they may talk, but they talk through this director. So this form dialog director is a mediator between the widget and the form director knows the widget, and so this director knows the widget. In other words, it will keep will have an instance variable that keep a reference to the widget. So this form dialog becomes the hub of the communication. So this is one example. So this one example show the dialog. You can consider this one is to initialize the GUI. So you create all the widget and put it in the right position of the window, and then you assign them the initial value. Then you are waiting there, and then the program is waiting for users input. And then so user input, and if this list box changed, then it's called the widget changed. So tell the director the list box changed, and then of course behind that you can think of is an if statement. Okay, if the list box changed, then I get a selection, then I set the text, then I enable this button. So this is all the actions is after an if statement. If I sense the change is from the list box, I do the following. So if the change is from this entry field, then I do different things. So you can consider behind the scene is a big if statement. So the class diagram is something like this. So here we have a dialog. A director is abstract class defined. Show dialog, create widget is to put the widget in different location and initialize them, and the widget change. So here is pulled by individual widget. So whoever change, then call this wicked change. Then for each, so this one is abstract director. Then we have a concrete mediator. So concrete mediator is individual windows. Is individual windows. So all the windows follow this interface. Then you have multiple windows. You have multiple windows. Then the windows can use the same. Different window may use the same widget, but they will use them differently. So here on the right hand side we have a widget. We have widget has a one method changed, and this changed will call this a widget change. We'll call this widget change. So this will allow the GUI knows that certain field is changed. And then this is a generic structure for the mediator pattern. We have a mediator and a concrete mediator, and then colleague, and concrete colleague. Collaboration. So the colleague send and receive request from mediator object. Then mediator implement the cooperative behavior by routing the request between the colleague. So I mean. The collaboration itself is quite straightforward. So all the communication, the request is sent by the mediator. So by using the mediator, we achieve the following. First is we simplify the protocol. Without mediator, is MN interactions. So I mean, the more object you have, then this interaction increase. Substantially. However, we can reduce MN to 1N. And also we abstract how object cooperated. So without using this mediator, then the object have to communicate with each other. And then you will see that this each widget contain an if statement. And then by using the mediator, then all the if statement we consolidate. We put it in one mediator pattern. So we have this centralized control. So this mediator can localize the behavior, otherwise distributed among several classes. And changing this behavior requires subclassing the mediator only. So by using the mediator, even there's a change in the widget, in the colleague, other colleague won't be changed. So we decouple the colleague. So when we use mediator, if a set of objects communicate in well-defined but a complex way, and then we can encapsulate. We can abstract this well-defined communication to one object. Or reusing an object is difficult because we refer to and communicate with many other objects. So if that's the case, one object change, then you have to change many other objects. So in that case, we can just let this object communicate with mediator only. So now the mediator communicates with other objects, so that when you change this object, it won't impact other objects. So you may think of the facades. I mean, on the surface, these two look very similar. So mediator is just among a set of objects, we create a mediator to handle communication, and the facade is also applied to the existing subsystem. So the subsystem kind of communicated, so we create a facade on top of it. So on the surface they looks very similar. However, the facade's purpose is to add a layer, to simplify the interface. So you want to communicate with the subsystem in a particular way, and then you can just define that particular way on the facade, so that you don't have to work with the subsystem directly. You can just call the facade to get the job done. But the mediator is to abstract the communication, abstract communication. And the facade is one way. Usually, it mean the client use facade and call the method in a facade, and then facade forward the request to the right subsystem object. But it's one way, and this mediator can be both way. So let's look at our dialog box example and how we implement that. First, we implemented the mediator. We implement mediator. So here we define the interface. We have a show dialog. Of course, is abstract. We don't implement that because each concrete GUI will initialize the screen differently. And we get change, and also each one is different. Now we create the widget. Then I see the widget. We see the widget. So each widget is different, but they're changed, and this method is the same. So this method is to tell the director I'm changed. So just pass itself as a parameter to the director. Just let the director know that I'm changed. So here, this change method is identical to all the widget. So we implement once in the widget base class. And then I see the concrete widget. So each widget is different. So we have a list box, entry field, and each one has their unique operation. And they have one thing in common is the change. This method is in common, so we implement once. And then the button, So from here we see that only button can inform the dialog, right? Only button can inform the director. So here one is a mouse movement, mouse click on it, then tell the director I'm changed. Then let's see the concrete mediator. So first, the concrete mediator must have a list of instance variable, that will hold reference to individual widget. Create a widget is like initialize the window, initialize the GUI. So you create the list box, and of course, in the real world example, you have to position this. Not just create a widget, and you should also position the widget, and assign initial value. Like the OK button is deactivate, and the OK button's box, the text is OK, and the cancel button is activated, and the cancel button and set task to the cancel. So here, for the widget, you have some initial value. So this is a create widget, and the heart of the mediator is this widget changed. So this one is like a bunch of if statement to implement the communication between the widget. So here, whenever a widget call this change the method and then forward itself to the widget change, then it will check to see which widget is changed. If the widget is least, I do this operation. If widget is if change the widget is a field, I do following, and so on. So here, this if statement can become quite complicated. It's a long list. It's a long list. So here we localize all the communication in one operation, in one method. So this one handle all the communication. So without this widget change, so you can think of this. The widget, they have to communicate with each other. So here we localize in one method. So if there's any change, we just change in one place. So so by using this kind of communication, we synchronize communication in one object, and then then this will reduce the maintenance effort. Then let's look at this exercise here. So here I want you to add a mediator to the existing design to synchronize the communication. And the scenario here is Bob has a Java enabled house, and all of his appliances are designed to make his life easier. So when Bob stops hitting the snooze button, his alarm clock tells the coffee maker to start brewing. So, but Bob want to have some more. Yeah, so no coffee on the weekend. Turn off sprinkler 15 minutes before a shower is scheduled, and the show alarm early on trash day. So here, the dynamic is very difficult to keep track of all the rules and how objects relate to each other. So this rule can may keep growing. If you change the owner, then owner have a different rule. So in here we see we have 4 devices. One is alarm, we have a coffee pot, we have sprinkler, we have a calendar, and they communicated with each other directly. So initial design is they communicated with each other directly. So whatever rule you put here is an if statement. If you let them communicate with each other, this if statement has to be implemented by individual. The device here. So if you have a new owner want to have a new rule, then the new owner must know how to set each of them. So that would be difficult. A new design is to have a mediator. Yeah, we add a mediator here. So this are all the devices. They don't talk to each other. So in other words, they don't keep a reference to each other. So they just keep a reference to the mediator. So whenever they want to do something, they send a request to the mediator. And how mediator knows what to do? So because a mediator have this big if statement. Yeah, it's very similar to our GUI example. So here we handle all the rules. So whatever rules you have here, we just handle in one place. Yeah, in one place. If it is alarm, we do things. If it's a weekend, we do different. If it's trash day, then we do things differently. So all the communication and all the rules we implement in the mediator. So if you have new rule, you just keep adding to this mediator, keep adding this if statement. So here I only illustrate that for this Java enabled house, change from without using without a mediator and with the mediator, but I didn't provide the design. I didn't provide a UML class diagram, and I didn't provide the source code. So because this problem can be is a candidate of your final exam. So please work on this on your own after the class.
I have a question.
Yes.
So in the situation where the system or some other part of the system would change one of the say one of the widgets, would it go through the mediator first? Or is the mediator only?
The mediator only handle the communication. So if the change is just localized to the one widget without sending the request to the mediator, then you don't have to change the mediator. Yeah, if you change the behavior that will impact the way you communicate with the mediator, then somehow the mediator should be changed as well. Yeah, but that's something we don't want to do that. Yeah, we don't want to do that. Yeah, it's better not to change. But it's this design doesn't prevent you from changing anything. Okay, the last pattern is observer pattern. So this observer pattern intent is to define one-to-many dependency. So this one is like a broadcasting. So if I change something and then I want everybody know. I want all the dependent node to change, notify and update automatically. So this one is like a broadcasting, try to implement this broadcasting behavior. And then the object we call observer are registered to an event, to observe an event raised by the observed object. So that observed object we call the subject. So in this observer pattern we have two players. One is observers, and the subject. So subject raise the event. So subject if they change, so yeah, I have a change, then the observer update automatically. So let's look at the one typical example here. For example, like if you use the Excel and you have this experience, you have the data, and then you can have a different display of the data. So data has a table view, has a bar view, has a pie view. So when you change the data, these views are changed automatically. So this is if you use the Excel, you notice that. Then but how this data we call the subject, and observer we call this a different view is like observer. How they communicate with each other, and this how this subject inform observers. So that's what we will discuss today. So here we use a different example to illustrate how they communicate. So in here, suppose that you have a weather station, and the weather station collect humidity, the temperature, and the pressure, and you save this three data into this weather data object. Yeah, you save into this data object. So this data object contain these three data, and then you have a different view. We call it display here. So the view we have is we have a current condition, we have the statistics, we have some forecasting. We have different view. We have different view of the same data. So whenever there's a change in the humidity, temperature, and the pressure, then of course the view change. So we want to set up this connection. We want to set up this communication channel. So here, this of course to do that, this weather data class has a three getter method to get the new data, and of course this measurement change, the method is called whenever there's a change, and then we have a three view to support. Is one is the current condition and weather statistics and the simple forecast, and one system should be expandable. So this means I can have a more display. And if I want to change if I want to remove some display, I can do that. Yeah. So I want to have some flexibility to change the view. So this is initially the weather data has this three getter method, and the measurement change. And your code goes here. If this measurement changed, then I update the views. So initially your design may be something like this. I just put everything in one method, three getter, and we have three getter, and then I have these three views: current condition, and statistic, and the forecast. So this shows that the data, the weather data containing data, and also is responsible for showing the view, showing the different view. So we encapsulate everything in one object. So of course, if the system is not expandable, then it's okay. But we say in the future, I can, I want to remove some view, and I want to add some view at a real time. If that's the case, we cannot use this design. So to achieve that kind of flexibility, we have to use observer pattern. Observer pattern define one-to-many dependency between objects, so that one one object changes state, all dependent are notified and updated automatically. So when we use observer, so whenever you see if there's a broadcasting pattern, then you can use this observer pattern. So let's make it simple. So you have a subscription and want to update it to your subscriber automatically, then observer pattern is a choice. And then this is the generic structure for the observer and the subject. So we have an interface for the subject, and this interface defines three methods to attach, to register observer and remove observer. So here is give you the flexibility that how many observers you can have. And then notified observer. So this notified observer, you can think of this notification is just like a for loop. You run through all observers you have, and then you call its update method. And of course, this update is to retrieve the data. So there's two ways to retrieve the data. Either you give the data, or you give the location of the data. So that's a two mode of communication: push and pull. And and then we'll show you the example, the differences of push and pull. So anyway, this notified observer is to run a for loop to call the update, and then this update is to retrieve the new data. So here we have a subject interface define the attach, detach, and notify. Define their signature, and then a concrete subject will implement the interface. So the observer define the updating interface, and the concrete observer implement this update implement this method. So let's look at how they collaborate. So first, the concrete subject notify observer whenever there's a change. After being informed the change, the concrete observer will retrieve the data. So this is a two-way. One is notify you, and then you retrieve the data. So the collaboration itself, just if I look at here is not that complicated. So let's see the consequences of using the observer. So first, we abstract the coupling between the subject and the observer, because all subject know is that it has a list of observer. As for who is in the observer, the subject doesn't know. So doesn't know any concrete observer. Just know I have a list of it, and I can change the list anytime I want. That's all subject know. And also the observer can support broadcasting. Broadcasting. Okay. So let's look at our example here, the weather data. The weather data. So here the weather data, we have an interface subject, define a signature for register observer, remove observer, notify observer. And then we have concrete subject here. So this concrete subject is the weather data. So the weather data will implement register observer, remove, notify, get temperature, and three getters, and the measurement change, and set measurement. Then observer interface. So here we have a then for the observer we have observer interface that will implement the update. And then here we have a display element interface. So this one is optional in this particular example, because so here of course we are talking about three different views. Then it will display the same data. Display the same data differently. So they have their own display method. So this update is to get data, and display is to display data. So in our example here, we only demonstrate how to update data. So this display, we just let another interface to handle that. So we don't implement this display here. First, let's look at the three interfaces. So the interface itself quite straightforward. Just define the register, remove, notify, and for the observer, only one method, update. For the display one, has only one method, display. So the interface is quite straightforward. Then let's see the subject. Let's see the subject. So in here, to keep a list of observer, we use array list. So we use array list, and when we create the weather data, we already create a new array list. And of course here the observer is has nothing in there. Then let's see the register. Register is to attach the observer to the subject. So this register is quite straightforward because this observer is array list, so I can add. So when you pass observer, then I can add to this array list. To remove observer from the list, we first check if that observer is in the list or not. So first we check the index of this observer. And of course, if this observer in the list, then this index is not zero. It's not zero. Then I can remove it. Then I remove that one. So this register and the remove. This implementation is straightforward here. The next is to notify. So as I said, the notify is just a for loop. So depending on the size of the array list, then I just run through the list. First, I get an observer from the observer list to get observer here, and then I call observers update. But in here, when I call the update, I push them the data. I give them temperature, humidity, and the pressure directly. So here I just so when I call the update method, I give them the data directly. So this one is like a push. Method. And there's another way we call the pull. So can you tell me what's so in here, if I try to implement in not using the push, I use the pull, then how I should implement it, and what should I do that? How should I do that? Pull is not, I don't give you the data. I either give you a flag, or I give you a flag plus the location of the data. Yes, how do you do that?
So that would be like polling, where it's on a forever loop, and you just ask for the data every time?
Yeah, that's a pull is like I don't give you data directly. Push is I give you data directly. Pull is I give you a flag. The data is available. Come to get it. Yes.
You could probably just like call the update.
Yeah, just update without doing anything.
In the update, you would call another function backwards to pull the data backward. The update function would call like the actual subject.
Yeah, so that's depending on how you implement update the function, right? Yeah, so yes.
So you'd have to have like a get temperature interface or something for the subscribers to call once it has like once they know they have new data, they can then
yeah, that's one way to do that. So especially when data is big, So in here at least if you save data in somewhere in here, you must tell the location of the data. So basically, the pull is to tell the observer the location of the data. So here also give you the example that one we use a push and one we use a pull. So can you tell me one we use a push and one? So in what situation we use a push, and in what situation we use a pull? Yes.
If the data is complicated or there's a lot of it, or you don't know how the data needs to be processed by the different observers, then you would want to use a poll because they can just figure it out themselves. But if it's a simple piece of data that you would always need, regardless of who the observer is, then you can do a push.
Very good. Yes.
Also,
Yeah.
like, if different observers need like just little select of different pieces of data, it would be useful for a poll, so you don't have to send all the data, but instead
Exactly.
it can poll select.
So basically, you just want so in summary, if you want to give observers some more control on the manner you get the data, then you use the pool. So most of the time is depend on the size of the data. For like here, I mean, this is just 3 float. Even I have 100,000 subscribers, this is not a big deal. I just give them data because the data size is small. But if here is not a float, it's a video. There is a video, and you have 100,000 subscribers. You give them video, that's where jam your network, right? So here in that case, you just tell them, hey, I have a new video, come to download. So that's so that's then when data is size is big and complex, we use a pool. When data is as simple as like this, we use a push. Okay, so here we have this. We have this for loop. We have this for loop, and then we have this measure change, and then we have set data is where we feed the data. Is where this data object obtaining data. So you obtain the data, you have new temperature, new humidity, new pressure. Then I call this measure change, and then this measure change will just forward to just call this notify, and then go this for loop. So can you tell me, in here, why bother we have this measure change? So why just this set measurement to read the data, and then I call this notify observer immediately, without calling this measurement change, and this measurement change do nothing, just but a forward request. So what's the point of having this here? Can you think of a scenario? Yes.
I mean, if you want to change from a push to a pull, you then want to use the notify?
If you change the push to pull, what you need to change is just update. It's just update. So my question is why I need this something just to do one forward method. There's nothing here. And what's the point of introducing this additional step here? Yeah.
That allows you to invoke the notify from other areas. So it doesn't have to only be from the set measurements. Other methods could invoke that too.
Yeah, that's one thing. Other can do that. Actually, one of the most important function. The purpose of having this one here is you can have some additional control here. For example, okay. If the observer doesn't want to be bothered anytime you change temperature, humidity, and pressure, it says, okay, if the temperature change is more than 10 degrees, then notify me. Then you can have if statement here. Then you can do when you notify. Okay, please keep in mind that this one gives you some additional control here. Yeah, give you some additional control here. So keep that in mind that in your final exam, this one is very likely, if I ask you to have some additional control, it's not just whenever data change, you notify. Yeah, you can say one data change is larger than certain threshold, then you notify. Then this measurement change will give you the way to control it. Then let's see the update. And then see the observer. Observer interface. Has only one method update. And then we have a different view. We have a forecast view. So here we only, I only show you one example forecast. Then of course you have the current situation and the statistics, and they all look similar. So in here, so you have this. Things to read the data, flow, the current pressure and the last pressure, and so on. And here you have a reference to the weather data. have a weather data. And then here is your update. Here's your update. So of course here we use a push and it give you data directly. Then what you need to do is very simple. You just get the data and call the display. So very straightforward. So if this one is a pull, is not a push, is a pull. And then what you need to do is, since you already know that in the weather data, the data is, this pressure is on the pressure. So you can just say this pressure is weather data dot pressure. So you can just get the data from it. So here is when you know the location of the data. If subject put the data in a different location, then in here, in this update, you must pass the location of the data. Then this observer can retrieve the data. So that's a pull mode. Then, this is a client. I create new weather data, and I have a view. Here. So to register, I just call the weather data as register observer. Here I register forecast. So if you have more view, I can just register more view. And then the set measurement is to feed the data. Anytime you feed the data, so from here, I call this set measurement, I feed the data, and then its measurement changed, and then runs through this for loop. So this is how this forecast display keep getting the new data. And let's look at this exercise. So here I want to use observer pattern in a situation where register investor are notified every time a stock change value. So investor is defined by name and stock is defined by symbol, like IBM and the price. So the stock defined by the name and the price. And assume that there's a 3 concrete investors, John, Mary, and Grace. And there are 2 concrete stock, IBM and Microsoft. And John and Mary is interested in IBM and Microsoft stock, and Mary is interested only in IBM. So here I wanted to draw the UML class diagram and provide implementation. So here I didn't give you the implementation because this one is very likely become your final. So let's keep it this way. So one of today's exercise, one of them will become your final exam. So if this observer pattern become your final, I will ask you to implement what we discussed today. What we discussed today is not a simple change. Okay, the change with a condition. Change with a condition. And I want to implement a pool. Using the pool instead of push. So here, please make a note. I didn't put in here, but I said, totally in the class. So for the distance student, if you don't watch if you don't watch this video, and then you will lose some. And then you don't know what I'm talking about here. Okay, let's spend some time working on it, and then let's spend 5 to 10 minutes. This is for the draw the UML class diagram, and then think of afterward how you implement this. So here I give a UML class diagram for this one. So here we have a stock at the IBM, Microsoft, and the investor. So of course here, so investor has a name, so you can have multiple investors, and then they can register to IBM and Microsoft for different investor. Okay, so let's go back here. Let me ask you a question. So here as I said, if there's a condition, then we implement it here, the measurement change, and that condition is applied to all observers, right? Is applied to all observers. So what if each observer's condition is different? Yeah, for example, here I have a 3 view. One is a current view, future view, and the statistic view. If statistical view says when the temperature is more than 10, give me the data. And the current view says if more than 5, give me. So if each one is different, then where should I implement that differences?
Yeah, in the observers.
Notify observers in the
Fine.
loop.
So where? So,
The for loop.
in the for loop, right? Exactly. So that will be in the for loop. If each observers have a different condition, then you cannot implement it here. So this one is the condition applied to all observers. If everyone is different, then you have to modify this for loop. Add the if statement here, blah blah blah. Then do things. Okay. Very good. Yeah. Because in this example, each investor may have different expectation, right? Yeah. So it's very likely that you in your program you have to have the if statement inside this for loop to accommodate that.